Hello everybody. This is section 3. We're going to talk about Internet protocol, a routed protocol, and the related routing protocols that control it. Now, remember, at the network layer is IP. So when you're talking about the Open Systems Interconnect model, the network layer is related to routing movement of information from the client there to the server. Remember, what will happen is inside the client, all of the previous layers of data will be put inside a new header. The new header is called a protocol data unit, and you'll add a network header, and in this case it's IP. Notice that the transport PDU, protocol data unit, is what you add the network layer header to. Now you have the server, and at the server the information is read inside the network header, and they look at the protocol data unit, and then they look at the protocol ID inside the IP header and pass the information to TCP, or the transport layer protocol in the OSI model. Again, a different view. This would be the side view again, but the key to this is also to note that, notice the pictures of the routers below, but notice that TCP passes data to IP passes data to Ethernet inside the client, Ethernet passes data to Ethernet at the router, and then the router extracts the data inside of router A and looks at it, passes it on the outbound portion towards router B. Router B has a separate link between router A and router B. The data is passed across that link to router B. Router B takes the data out of the Ethernet frame and looks at it, takes it and puts it on the outbound portion inside a frame relay frame, and that goes across the wide area network to router C. Router C takes the data out of the frame relay frame, puts it inside an Ethernet frame. The Ethernet frame and the Ethernet protocol moves the data from router C to the server. The server extracts the data from the Ethernet frame, determines that it's IP, passes it to IP, and then IP looks at the protocol identifier and passes it to TCP. That's a detailed look. The key here is we have 4 separate links that IP routes the data across in order to get it from the client to the server in what is known as Route 1. Here's Route 1. Notice the data is moving from the client to the server through routers A, B, C. There's another route available. This is Route 2, and it goes from, here we go. Now here we go, this is Route 2. It goes from the client to the server, but it goes through A, F, E, and D. And the key is routing is the decision that is made at A. Do I go left or the upper way, which is routers B and C, or do I go right, routers F, E, and D? The key that normally decides this decision is either the number of routers you got to go through to the destination, or the capacity and delay that you would have going one direction. If they're going through the number of hops, or the number of routers you got to go through to get there, which is the protocol RIP, you'd go on the upper path. If you're going delay and bandwidth, you would go through F, E, and D. Even though that's the longer route, it's got the best delay and bandwidth.